were asking me. So my name is Ron Evo. I'm the CTO of cPacket, and I'll hand over really quickly to Norm. But what we wanted to explain is the AI for network observability. And for us, AI for network observability came from exactly the questions that you guys were asking me. So think about it as the reason we're using this pyramid is if you think about data, information, knowledge, right? Then packets are the raw data that we're using. And one C-store in a hospital group sees about 1 trillion packets a day. Raw data doesn't mean anything. We're very happy that we were able to make it into a dashboard, right? And you still, get tens of billions of these sessions. And if you're a network expert, it's useful, right? But that's not really, it doesn't scale. Even this doesn't scale, right? It allows me, okay, someone called. So how can we take all these tens of billions and make out of that the 3 or 4 insights that a normal human being operating a network can handle a day, right? In a way, can we do an easy button, right? What is the easy button that takes all these tens of billions of packets and give you the few insights that are useful, right? So that's what we're gonna explain, how we do that. But I'll hand it over to Norm here.
Awesome. Thank you, Ron. I'm Norm Bright, again, Senior Director of AI and Cloud for cPacket. So I want to give you guys just a real quick overview of what we're going to be looking at. However, I got a big asterisk to put in here. So this is currently under live development, pre-preview on our live network. So you guys heard Murphy. When he hears all of those things, he shows up. So bear with me as we get to...
I'm right here.
I know, fantastic. I love it. So we'll give you guys just a quick overview of what we've got. So this is our current deployment, but in a customer's account, what we would expect to see is they'll have on-premises equipment deployed. That's going to be feeding a common metrics or a common metadata store that we've got. We have, obviously, cloud pieces as well, and that's why I'm here. So, and also, this is actually going to be running in the customer's account. So this is not today currently set up to run as a software service. So we're going to say, look, we want you to be in control of your data. We want you to be in control of access in and out. We'll give you everything to deploy this and set it up in your environment so you feel like you've got complete control over what's going on, right? So because we're going to do some analysis and we're going to show some data and it's going to be exciting here. So so I'm going to go to the live piece and give you guys the quick overview of it. Okay, so hopefully it shows up well. This is kind of our current homepage, right? And Ron was saying we're actually showing a handful of insights. Okay, this is my development box. I've got this, what I would consider running wide open. I got every insight I'm seeing come into this. I'm not filtering anything because I want to see how my models are doing. So I'm going to show you some of the views of what the models are collecting on the back end, and you can get an idea of what we have. So roughly per day, we see about 30 million connections out of our cPacket network. Our network is actually pretty small. So overall, boy, your mouse is faster on. I just have a real quick drawing here of what our network looks like. This is our internal network. These are just IP addresses rotating around. You can see we got some evil overlords there watching all of our servers and stuff like that. Just gives you a quick idea. We're seeing about 70,000 incidents a day. So let me talk about an insight and incident. An insight is something that's built on one or more incidents. So when we see something that's anomalous, we're going to go, oh, is this really anomalous or not? And we'll cut an insight for it if it needs to be presented to the user. And that's going to be configured by the user through user feedback. What's important, what's not important. And we do that through actually presenting a summary of what those insights look like. So on this page, these are actually live, so bear with me. And you can tell that because last incident time was today. And in this case, we are summarizing what it was, when it happened, where it happened, and to give you sort of an indication of what why looks like.
When this product is eventually delivered, does the box come with some of these insights pre-configured? Or
absolutely, yes. Okay. So the models that we have are trained, right? Mm-hmm. They'll learn also in the customer's environment. This particular model is using what we call an average diff model. So it's looking at normal behavior in the network for sessions, connections, latency, performance, anomalous sessions, things that appear, things that don't appear, and what's unusual. And previously, Ron showed you the different monitoring points we have in our network. We've got monitoring points spread out all over the place, so we're getting a lot of data. We see things on the DMZ, outside the DMZ, and inside as well. Those models are all built and trained based on what we believe to be a good AI model. And when it goes to the customer's network, it's going to learn as well on what their network is and how it works.
So it's going to basically auto-detect, say, microbursts
Yes.
out of the box and say, hey, a microburst happened right here in this network at this time.
Perfect. You're on those excellent questions again. I just love it. Fantastic. I want to show you one. Oh, sorry.
Yes, I wanted to just kind of follow up on Jeremy's questions, especially Murphy. As you take your model out of the box and you put it in customer's environment, how long are you recommending for it to tune on the customer's data before it's
So what we've seen so
basically
far is
production ready?
we want about a week,
Okay.
right, to get a look at. So I'll show you in one of the cards that I've got here. I call them cards. Other people call them insights, so bear with me. This is an example of something we're seeing on our own internal network, right? This one probably is going to take a little bit of time to learn, right? Maybe about a week or so. We'll see what's normal. Depends on the day of the week. We have elements like periodicity. How often does this happen? And so you kind of see within the context of where it's happening and when it's happening. So in this card, this is essentially what, when, where, and hopefully why eventually. So we get to the point where we're saying, we think this server is having some sort of impairment on resources, right? What server is it? Well, how do you know that, right? Well, what we're actually seeing is we're seeing the server reduce TCP window size unnaturally, right? Normally it doesn't do this. And it is actually, oops, drop the mic. It is actually occurring fairly frequently. So we're like, oh, I understand what it is. So what is this server? This is actually our LDAP server, right? So it's, I don't know what's going on, but in general, it actually has, and you can see down here, when these events occurred, who the clients are it's talking to, right? What its IP address is. And we actually have also metadata or tags associated with different groups, right? So when you build your network and you define it, you actually lay out these tags, you classify things. That'll become important in the next demo I'm going to show you. But you get an idea of where things are, what's happening, who it is, and then why. So the card is trying to convey and deliver all that information to get you to a point of understanding. So you might not have the responsibility to fix it. You might go work with your apps team or your server team or something like that, or potentially a cloud CSP to help you as well, right, to resolve those problems. But this is an example of a server latency card, and this is still happening on a regular basis. And the next one's kind of a fun story. So when we deployed our models, we actually have them running and they're actually watching the network. And this card, or this insight is presented here, came from, it shows up as a security warning. We're like, well, what is that? So large file upload security warning. And even more concerning is that when you look at what, when, where, and why, these are actually IPMI BMC devices in our lab. And even more concerning, they're talking to external IP addresses. So, reacting to that is something that, yours truly was like, what, who, why? So turns out it's benign, no big deal, but it is actually a licensed version of Ubuntu from Canonical phoning home on a pretty regular basis. So this is actually something that we didn't know was happening, but we actually can surface it to the customer's attention and allow them to interact with it. Now, on this card, you actually can also, or on the insight, you can actually disposition it, right? If this is a non-issue, you can say, pause it. I don't really care, right? Put it in the background. It's not really important to me. So we're, again, taking that user feedback, instilling it on the platform, and then making things more relevant for them as they use the tool.
So if I was working at a FinServ kind of company, there's a kind of a regular cycle of traffic is, high in the morning or high in the afternoon. So something like there's a regular cycle.
Yep.
How do you deal with baselining irregular cycles? Is there a mechanism to say, hey, now is the time where I expect to see this, or now is the time I don't expect to see this, so that the insights aren't false positives? So
one of my favorite PEs I used to work with used to say there's no compression algorithm for experience. It takes time to learn that. Right. So over time, over a year, when we start collecting data, we'll know everything that happens during the year, right? Cycle times, quarter close, year-end close, things like that. April 15th for those in the US.
What if they're non-cyclical?
Yeah. What if they're random and bursting?
they're random and bursty, you're going to have to help tune the platform to come back and not recognize things. You're going to have to give that user feedback.
I mean, is there like an API into the system you can say, okay, I know I'm going to have, say, a maintenance window between these two time zones. So now if these interfaces are not spewing the right amount of traffic that you normally see, that's not an anomalous thing. It's like, is there a mechanism within the platform where we can actually help teach it on a case-by-case basis when that kind of situation occurs?
So where we're going, and this is not implemented today, is that we're building from the hard problem, from the packets. There's a whole bunch of other data scheduling from metrics, events, logs, traces, the melt data that can interact with the platform to help give us context on what's happening. So those interfaces, those APIs need to be built so customers can then give us some insights so there's not noise, right? If they schedule maintenance events and we know that there's always a terabyte of traffic between these two servers between this time of the day and it's down, yeah, we would call that out. That's a problem, it's missing. So we need to have some indication, some clue, right, from the network, either historically that we learned or told by them to us to be able to go off and do that.
So just to follow up on something that I think I just heard, are you planning on taking in syslogs and things like TACACS records to analyze those things in combination with these packet traces?
So again, starting with the hard packets first, right? Doing the hard problem because people can't see that. And we're getting a bunch of insights and information that can't be done normally, and working our way towards pulling in other data sources and logs. Whether that's a partnership or the technology we develop, we're working through that. Okay. And I'll skip the last one because I think we're going to run short on time, but hopefully this gives you an idea of the what, when, why.
One just follow up.
Sure.
First, bravo, thank you for saying AI and actually having something that shows some form of intelligence. And
Cool.
Second, so by example, in a financial services organization, we are always concerned about data exfiltration, right? Especially if you work with PII or PCI regulated stuff. So after having the platform in the network for 6 months, it would be able to say, we noticed that in this call center, after this particular agent finishes a call, there's a large data upload that doesn't happen from any of the other agents. And maybe you should look at that,
Exactly.
the packet data to see maybe that person's uploading card numbers or something like that. Is that where you're going toward?
Absolutely. Yeah. So detecting what's normal, and normal can be random chaos. It could also be very well defined based upon user behavior, right? So as we learn user behavior, as we land categories of users as they're tagged, you can get an idea of what they normally do and what's abnormal, right? What isn't something that you expect that's out of normal traffic that we've seen on the network side. So yes.